Why are planets and stars shaped spheres? Not only planets and stars, but many celestial bodies we see in the universe, stars, planets, clusters, galaxies either have a spherical structure or have a circular shape. So why is everything in the universe trying to form a global structure? What is the purpose behind this? All the events that take place in the universe take place under the laws of physics we know or do not know. While it is only a matter of time to find out what some of them are, we can explain many things with our current knowledge. Explaining globalization is also based on a fairly simple case. In fact, the question we asked at the beginning, what purpose is behind this, is wrong. As human beings, our emotional thinking makes us think that there is a purpose that is at the heart of everything. We do not know if this is the case at the end of everything. But what we do know is that events occurring in the universe are merely the result of the laws of physics. The sphere is a geometric shape in which the distances from its center point to its surface are all equal. We call this distance the radius. Wherever you go from the center to the surface, the distance you will measure is the radius itself. Therefore, the sphere has a perfect geometry and symmetry. We can use it to explain the spherical structure, as the law of gravitation mentioned by Newton is still in practice today. The masses in the universe exert an attraction to each other depending on their proximity. As a result of this attraction, they form groups, clusters, ultimately clustering. These groups and clusters gradually form a spherical or circular geometry. This is all the result of the gravitational force and the perfect symmetry of the sphere. No matter where you take a point on the surface of the sphere, the attraction force applied to each point is the same, since the distance will be the radius, r. So the perfect symmetry of the sphere creates a simple state of equilibrium. Laws are constantly happening, gravity is still there. But because the forces balance each other wonderfully thanks to symmetry, no effect is observed. Just like trying to push the wall, there is an equal response to action. If this equilibrium situation is absent, the structure will try to be global as long as the law continues to operate. A mountain on the planet will disrupt the balance of forces, causing geological effects. We can think of it as applying too much force to the wall and tearing it down. Ultimately, some point equilibrium is achieved by gravity, depending on the strength of the structure. This is something we don't see much of on planets. No planet is a perfect sphere. The reason for this is the resistive force due to the existing solid structure. That is, a sufficient force cannot be applied to break down the wall. Gravity remains weaker than the resistance exerted by the solid matter. Why aren't planets perfectly spherical? Every rotating object is thrown out of the equatorial region. When you spin a rope with a ball at the end, if you spin it at sufficient speeds, it will try to jump out. For this reason, a structure with a larger radius in the equatorial direction arises. This is why we express the radii of celestial bodies in two ways, from polar regions and equatorial regions. Because while this effect is the least at the poles, it is maximum at the equator. For this, you can read our article about disk formation. This makes it clear that the Earth is flattened from the poles and swollen from the equator. When we look at these values, equatorial radius, 6,378.1 kilometers. Polar radius, 6,356.8 kilometers. When compared to this average, it is a defect of 3 in 1,000. The Sun, on the other hand, has an almost perfect spherical structure. In Jupiter, which completes its rotation every 10 hours, the equatorial radius is exactly 5,000 kilometers more than the polar radius. This is almost equal to the radius of the Earth. As a result, the reason for this spherical structure we observe is that the gravitational force reaches a state of equilibrium in the sphere which has a perfect symmetry. A new video every day. Don't forget to like the video and follow the channel.